Good morning all. So welcome to the fifth lecture of the subject basic electronics engineering. In the last lecture I discussed the conversion of octal, binary and hexadecimal among these conversion among these bases, base 2, base 8 and base 16 without involving base 10 in between. And I told you if you have to convert octal number into a binary number, represent every digit of octal number by 3 bits. For example, I took this problem from octal to binary. I represent this 4 by 3 bits, this 3 by 3 bits, this 6 by 3 bits and so on. And if I have to convert a binary to octal number, where I took this problem by converting this to convert this binary number into octal number, you make a group of 3 bits in the integer part from right to left, and for the fractional part from left to right. If you have, you can insert zeros here as well as you can insert zeros here, which doesn't affect the result. So let's take one problem. I have done octal to binary and binary to octal conversion. Let's see how to convert a hexadecimal number into a binary number. So before I come to this, few students ask me that how did I make that table, or do we have to learn it or mug that table up? No, you don't have to mug it. You can simply apply the logic. By applying the logic, you can make the table. See how to make this table, which I discussed in the last lecture also. Suppose I say that you have a decimal number. Decimal number, I am writing only D, not complete decimal, means base 10, and you have octal number. O means octal with base 8. Then let us consider hexadecimal also. Now, in octal number, you have the largest single digit number as 7. The digits which are available in octal numbers are from 0 to 7. So in decimal, 0, 1, 2, 3, 4, 5, 6 and 7. That is, these are the numbers with base 10. In octal, of course, this will also correspond to 0. This will correspond to 1. This is 2. This is 3. This is 4. This is 5. This is 6. And this is 7. Of course, decimal 8 in octal will be represented by a different way. That is another point. So if I have to convert this number, this particular number, into binary, so I represent this by 3 bits. And how I represent this by 3 bits, I'll simply write here as okay, I'll use this color. I write here simply 1, 2 and 4. 8 I'll write later on. 8, 4, 2, 1, although it is. So 0, what I do, I write here this 0, 0 and 0. Now as far as 1 is here, I write 1 here below this 1 and rest 2 are 0. 2, I write 1 below this 2 here and then it is 0, 0. 3, 2 plus 1 is 3. I write 2 plus 1 is 3, rest are 0. 4, I write 4, 1 below this 4 and 0, 0. 5, 4 plus 1 is 5. 4 plus 1 is 5 and rest are 0. Similarly 6, 4 plus 2 is 6 and rest is 7. And 7, 4 plus 2 plus 1 is 7. See, these are the corresponding octal number represented by binary bits, or there is a corresponding binary number also. I can say 7 in octal is equal to this much in binary. Now let's come to hexadecimal number. That suppose I have hexadecimal number also. Let's take hexadecimal number. I am representing hexadecimal number by H. You have this H means base 16. Now in hexadecimal number, in hexadecimal number you have from 0 to F, which corresponds to 0 to 15 in decimal. So I have numbers 8, 9, 10, 11, 12, 13, 14 and 15. How to represent this? Of course, in hexadecimal 0 corresponds to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 in decimal corresponds to A in hexadecimal. In decimal, if you have number more than 9, you need 2 digits. Above 99, you need 3 digits. But here, above 9 also, up to 15 can represent by single digit. 11 corresponds to B, 12 is C, 13 is D, 14 is E, and 15 is F. Now, how to write this in binary? It is represented by 4 bits. Now, I am using 8421. Where you have red and green color means that is representing the equivalent binary number of the hexadecimal, and if this is only red, So that is representing the octal, that you try to understand. So look at this 0. 0 is 0, 0, 0, 0. Again 1, I write 1 below this, rest will be 0. I need 4 bits now. 2 is same, 3 will be 2 plus 1, 3, 4, then 5, then 6, and then this is 7. Now come to 8. 8 is here, I write 1 below this 8 and rest will be 0. Look at this 9. 9 means 8 plus 1 is 9, so I write here 1001. This is 9. 10. A corresponds to 10 and 10 is 8 plus 2 is 10, so I write here 8 plus 2 is 10. 11. 8 plus 2 plus 1. 8 plus 2 plus 1. 1011. 12. C corresponds to 12. 8 plus 4 is 12. 13. 8 plus 4 is 12 and 1 13. Then 14. 8 plus 4 plus 2 is 14. And 15. 8 plus 4 is 12, plus 2 is 14, and 1 15. This is how you frame any table. These are representing the corresponding only this 8 by 3 bits octal, and with 4 bits it is hexadecimal. What I mean to say that suppose you have 9. Suppose I say that you have number 9. This 9 in hexadecimal is 1001. In octal, this 1 will be by 3 bits. It will be 001, and of course 9 you can write. It is 001 here. For example, 7. Okay, let's not get confused. 7. In octal, 7 is 111. In hexadecimal, the 7 is 0111. That is the main point. So let's come to the problem which I started with. I have to convert this number into binary number. So 7, I'll represent hexadecimal to binary, means I have to convert this every digit of hexadecimal number by 4 bits. So this 7 is 0, 1, 1 and 1. Say this 7. In hexadecimal, it is 0, 1, 1 and 1. Had it been octal, it would have been only 1, 1, 1. So this is the main point. A is 10, so it is 1, 0, 1, 0. 5 is 101, 0101. C is 1100. You can refer the table. The C is 1100. You practice some problem, you will be perfect. Point E. If you see, E corresponds to 14, 1110. Say this is 1110. And F is 15, so it is 1, 1, 1 and 1. I hope that this problem is clear to you. This is my final answer. Now suppose I say that I have a binary number. Let's take another problem. This is the first problem. Let's take another problem that I have a binary number and I want to convert into hexadecimal. Suppose I have a number, right, with some gap here. So I have a number 1, 1, 1, 0, 1, 1. That's all. 0.101110. Suppose I say that I have this number in binary and I say that convert this, it is equal to how much in hexadecimal, in base 16. So it is simple problem that I have taken, how to convert a binary to hexadecimal. Binary means I am writing only by B, and hexadecimal base 2 and base 16. So 2 to the power 4, so I'll represent by 4 bits. You can see here also it is 2 to the power 4 here. So that's why I represent every digit by 4 bits. I have to convert this into, so now I'll make a group of 4 bits. In the integer part, I'll go from right to left. Now I don't have 4 bits here, so I can insert zeros. That will not affect my result. I make a group here. Similarly, for the fractional part, I go from left to right. I don't have 4 zeros here, 4 bits here, so I insert 2 zeros. So I'll have a group of 4 bits here. Now I write down the equivalent of this. What is equivalent of this? This 8, 4, 2, 1. If you see, this is 11. 8 plus 2 plus 1. This is 11, and 11 corresponds to B. So I can say that this is B. This is simply 3. Just write down 8, 4, 2, 1. 2 plus 1 is 3. Again, this is 8, 4, 2, 1. Further, again this is 11. So it is B. Okay, coincidentally it is like this. Otherwise not necessary. So, and this is 8. So final answer I can say that this is equal to 3B point B8 in base 16. Now suppose I say that I ask you the same problem. I say that convert this number into base 8. Let's take another problem here. I'll take another problem. If you have this number here, this one only, 111 0 1 1 0 1 1 111 0 1 1 point 1 0 1 1 0 1 0 1 1 0. Suppose I say that you have this number in base 2 and I say convert this into base 8. Now 8 is 2 to the power 3 here if you see. So I'll make a group of 3 simply. I'm making a group of 3 bits. Let's go 1 2 3 1 2 3. Yes. And here these 3 and these 3. Okay. Now this corresponds to 3. This corresponds to 7, this corresponds to 5, and this corresponds to 6. So it is 73.56 in base 8. I hope that this problem is clear to you. So if you have to convert into 16 or into base 8, you make a group of 4 bits and 3 bits correspondingly, respectively. Let's come to one more problem. So I have told you how to convert octal to binary, binary to octal, hexadecimal to binary, or binary to hexadecimal. Let's take another problem where we have to convert octal to hexadecimal or hexadecimal to octal. So there's a problem here. Suppose I have a hexadecimal number. Suppose let's say I have a hexadecimal number. I have hexadecimal number, suppose 6BE.4F. This is in hexadecimal, base 16. And I say that how much is this number in base 8. Now, one way I told you in previous lectures that you go to base 10 and from base 10 you convert this into base 8. In order to convert this into base 10, you will have to express this as a sum of its weights. Then you will get a corresponding number in base 10. Then for base 10 to base 8, you will have to multiply and divide it by the number 8. Okay, successive division and multiplication for the integer part as well as the fraction part. But now I'll go via base 2. The procedure that I'll follow is that if you have a number, suppose I have a number, look at this. For this, if you have a number n1 in base 8, and okay, I'm dealing with 16, let's take it 16. You have a number n1, I'll write it fresh one. You have a number n1 in base 16 and I want to convert this into number n2 into base 8. So what I do, I convert this into another number base 2. I'll go via base 2. I'll convert this base 16 into base 2 and then this number of base 2 binary number into a octal number, or I can go vice versa also, same thing. So let's do a solution of this. Let's find what is the solution of this particular number in base 8. So very first thing what I do, I convert this into base 2. First step is this. I have to convert this into base 2. In base 2, every digit of hexadecimal number has to be converted into 4 bits. So this 6 is 0, 1, 1 and 0. See 6. This 6 in hexadecimal. If you see 6 is 0, 1, 1, 0. Then B. If you see that this B is 11, 1, 0, 1, 1. 8 plus 2 plus 1. So B is 1, 0, 1, 1. Then E is 14. E corresponds to 14. It is 1, 1, 1, 0. Point 4. Simply 4 is 0, 1, 0, 0. And this F is 1, 1, 1 and 1. This is the corresponding number in base 2. I have done up to this step. Now if you have to convert this base 2 into base 8, my next target is to convert this base 2 into base 8, means I'll make a group of 3 bits. I know how to convert binary to octal by making a group of 3 bits. So from here I am making a group of 3 bits. These 3 bits, 1, 2, 3. These 3 bits, then 1, 2, 3. These 3 bits, and then 1, 2, 3. Okay, fortunately I don't have to insert any 0. Then these 3 bits, 1 0 is less, 1 2 3 4 5 6 7 8. Yes, we have 8 bits, we need 9. So I'll insert a 0. This is how I have done the grouping. Now 1 1 0 is 6, 1 1 1 is 7, 0 1 0 is 2, and 0 1 1 is 3. Please cross check it. There is a possibility of a minor mistake. Okay, I want you to point out if there is any. This is 2, this is 3, and this is 6. 0 1 0 is 2, 0 1 1 is 3, and 1 1 0 is 6. So my final answer is 3 2 7 6.236 in base 8. So this is how I have converted this base 16. This number base 16 is converted into base 8 via base 2. I have not gone into base 10. So this is as simple as it is. Let's take one more problem where I have to convert a octal number into a hexadecimal number. Although it is not required, but still let's take one problem. That is, this is simply hexadecimal to octal. Let's take one octal number. Suppose I have a number 742.56. This is base 8, and I say that how much this is equal to in base 16. So base 8, initially what I'll do, I'll convert this base 8 into base 2 and then the resulting base 2 into base 16. So again, in octal number, if I have to convert octal to binary, I have to represent every digit by 3 bits. So this 7, look at the solution. The 7 corresponds to 111. Then 4 corresponds to 100 by 3 bits. The equivalent of 2 by 3 bits is 010. 0.5 is 101. And the 6 is 110. This is the corresponding number of this in base 2. In base 2. Now I have to convert this base 2. This is equal to how much in base 16? Okay, so it is, this 16 is what? This 16 is 2 to the power 4. So I'll have to make a group of 4 bits. Similarly, just as I did in the previous case, for the integer part going from right to left. 0010. 1, 2, 3, 4. This is what it is. Now I don't have zeros here, so I insert 3 zeros, extra zeros here, and I make a group here. Then further, for this, left to right, then you don't have 4 bits here, I insert extra 2 zeros here, and this is what it is. Now I am writing the corresponding number for this. 0010 is 2, 8421. Then 1100, 8421. 8 plus 4 is 12, 12 plus 2 is 14, and 14 corresponds to E. It is so simple. Then this is 1, of course. Then again look at this part only. 8 plus 2 plus 1. 8421. See this. This is 8421. 8 plus 2 is 10, and 10 plus 1 is 11, and 11 corresponds to B. And this is 8. This portion is 8. So I can say that this is equal to 1E2 point B8 in base 16. So this is how I have converted base 8 into base 16. So if you have to convert any hexadecimal to octal number or octal to hexadecimal, you go via base 2. If you have to convert binary to octal or octal to binary, represent every digit by 3 bits or make a group of 3 bits. Binary to hexadecimal or hexadecimal to binary, make a group of 4 bits or represent every digit by 4 bits, you can see. So with this, I have come to the end of conversions. In the next lecture, I'll start with a different article. So thank you for the time being. Feel free if you find any difficulty, and if there is any minor mistake, please let me know. Thank you.